Welcome to Show Me Your Stack. This isn't a GTM podcast about frameworks or strategy decks. This is the build layer. Each episode, I sit down with a GTM engineer and break down how they're running go-to-market in production, the workflows, the orchestration, and the autonomous agents behind the execution. We go inside the stack. What's connected, what's automated, what's still manual, where it breaks and how it gets rebuilt. Because modern GTM isn't a funnel. It's a system of agents, data flows, and decision layers operating in real time. Today's guest is Vinayak Mishra, building AI native GTM systems across automation, evaluation, and agent workflows. No theory, no slides, just the stack. Let's get into it. Vinayak, thanks for being a guest with us today.
Thanks, Rick. Thanks for inviting me on the show. Thank you so much. It's a great opportunity to come over here and share my GTM engineering experience with you and everyone. So for this video, I would love to show a restaurant review intelligence system that I recently built. So without wasting a lot of time, let me just present my screen and take you to where the things are actually happening. Okay, so here we are on this restaurant review intelligence system. I'll take it in 3 steps. First, I'll tell you whom I built this for, and then what I built, and then for how I built. I have all my tabs open where the real workflow lies. So I built this restaurant review intelligence system for a company called Slang AI. Quick context about them. They're a very good company, just raised a Series B round, and they basically are into voice AI reservation system for restaurants. And the main bottleneck is that they need to find restaurants actively struggling with phone and reservation communication. So for them, I figured out that a review-led GTM workflow could be very good. And owing to that, like I built a system that basically tracks the reviews given by end customers at scale, which means like reviews across different platforms like Google Maps, Yelp, TripAdvisor, and a lot more. And then the system that I built finds the negative reviews that complain specifically about phone and reservation issues, because these are the problems that Slang AI's voice AI reservation system solves. Now I'll deep dive into an whiteboarded architecture for how I built this. So this is again a 5-layer architecture. I'll start with Serper.dev. That is basically a very fast and cheap Google search API. So the main goal for using Serper.dev was to gather the restaurants that are that can be found in Google Maps. Using Serper.dev, I scraped all the restaurants present in the US that were on the Google Maps. Then this restaurant data was sent into a master clay table, which I'll just show in a bit. And then I used a Apify actor, which is a restaurant review aggregator. So that helps me with my whole review workflow. And after that, these reviews are all these reviews that are fetched using the Apify actor are sent back to my n8n workflow, where it's like a central brain using Claude that filters all these reviews, funnels and brings out only the reviews that are relevant for Slang AI. By that, I mean all the reviews that are relevant or that are like negative and mention problems around phone and reservation communication. So let's quickly dive into the master clay table. So I designed a 3-table architecture for this workflow. The first table is like a master table that contains all the US restaurants. So here you can see 2 columns. These are all the localities and the states in the US, and the business type over here is restaurants. And using a Clay's JavaScript formula, we basically build a query that says restaurants in LA, California, or maybe restaurants in Harris, Texas. So using these 3 columns, this Serper query is formed. And next, these are the Serper HTTP requests that I'm sending to the Serper. I'll just quickly show you inside how it looks like. So as you can see, the endpoint we are hitting is Serper.dev /maps, because we want to fetch maps. But if you want for other use cases where you want like images, news, maybe places or videos, you can do that as well. So the query is very simple. We have our Serper query ready, which is in this column, and we want to scrape only one page. For now, I just wanted only 20 restaurants to be brought back. And then similarly, we create the Serper page 2, page 3, and page 4. And like you can continue to build this, so on and so forth. Or you can also use the pagination inside using an n8n workflow to continue scraping till the last, till like as many restaurants are available, because on one page of Google, only 20 results can be fetched. So this is my master table. And on hitting these Serper endpoints, I stored the data received into a new clay table so that I have only all the restaurants in the US in one single table. So for this use case, I ran it only for 3 localities. We can totally do it for all the localities and states in the United States. So these are the scraped restaurants, and as you can see, we get all the relevant info about these restaurants, like their name, website, the place ID, phone numbers, and the rating and price level details. Okay, perfect. So till here we have now all the restaurants. Now let me take you to the Apify actor that I've used. This is the Apify actor column. Let's go directly to the Apify actor. It's called Restaurant Review Aggregator, which basically takes the search keywords and the search location as input and brings back all the reviews founded for different review providers like Google Maps, Yelp, or maybe you can use TripAdvisor, Facebook, Uber Eats, and DoorDash as well. For this use case, I stick to only these two. So I set up like the HTTP request for this Apify actor over here. And yeah, let's see. I've already done some of the runs, so we can go to the logs and check. So let's pick the latest one. Amazing. So this particular restaurant called 70 and above brings back the who is the provider first of all. So these are the other reviews that are given by Google Maps, and this is the review text that the particular author has given, and it also brings back on what date this review was posted, as well as the rating of this review. Was it a 1-star rating, 2 or 5? Now comes the brain of this whole workflow, which is what I built inside the n8n. So I'll first tell you an overview what this whole workflow is about. So at the starting point, via an n8n webhook, we are receiving data from this Apify actor into our the n8n workflow. Remember here, I just showed like there are lots of different reviews and they have lots of different ratings. So here we filter only the reviews that are negative, and for that we need to filter the reviews that have less than or equal to 3 star ratings. And once after the star reviews filter is done, it goes into a Claude analyzer that basically checks if this negative review is relevant to Slang AI or not. Now, how that happens, I can quickly show you the prompt as well. So this is my whole prompt, and it basically asks us to act like a review analyst for Slang AI. It describes what the company does, and it gives like the relevant signals. For example, if a restaurant couldn't be reached out by phone on a busy day, let's say a Saturday or something, or maybe someone called multiple times but there was no response and things like that, just gave it some of the non-relevant signals, some of the examples and some of the edge cases, and it was working perfectly fine. And after this filtering of the reviews that are relevant to us, I just structured the output, and here it's like a simple if else statement whether it's relevant to Slang or not. And if it is relevant, this data is again structured back and sent it into our clay table in a third different table, which is the qualified reviews one. So without wasting any time, I'll just show you one of the execution that we have done. So let's go over here. Okay, perfect. So as you can see, this is the data that we received from our Apify actor, and this basically filters the data into the actor using dataset ID. So using the unique dataset ID, we bring back the results for a particular restaurant into this n8n workflow, and then here, yes. So here, as we can see, like 20 items were brought in because we set our limit to 20 only. So 20 reviews were basically fetched inside this. And then there was a check if the ratings is less than 3 or not, out of which 16 were discarded and 4 were accepted. So they moved further ahead. So next is the Claude analyzer that checks all these 4 reviews and filters out only the ones that are relevant for us. So these 4 items that were received as the low star reviews are passed into the Claude analyzer. I'll just show you how the analyzer works. Basically, it takes all the reviews inside and it gives the relevant reasoning for each review, whether it was like relevant to Slang AI or not. And then later, this data is passed into it marks it as true or false. And based on that, the data is again later sent back to the clay table. So the relevant reviews are passed into the later stage of this n8n workflow. And here just a bit of structuring is done in the output so that the data can be sent back to our clay table via an n8n webhook, so that the data can be sent back via a webhook. So let's see if the review was fetched over here. So as you can see in this third table, we have all the qualified reviews sent back that are like relevant to Slang AI. And let's see if the review that we fetched is relevant to Slang or not. So it says special request for daughter's birthday was mentioned during reservation, but completely ignored by restaurant staff. So as we can see there, it is clearly a reservation related problem, and our workflow worked pretty fine. So yeah, this was my whole workflow, and this is how you can build basically an end-to-end automation. For this is especially very useful for local businesses or like small and medium sized businesses motion. So this is an automation that you can replicate whenever it comes to selling to SMBs or like HVAC or restaurants.
I want to say stage 2, orchestrated workflow. Not yet stage 3, fully autonomous AI agent workflow. Is that an accurate statement, Vinayak?
Yeah, yeah, correct. So basically, I just designed an MVP of this. Of course, like in the third table that I showed for which had all the qualified reviews, from there you can enrich the restaurant's info and basically take it right from there and like do all the personalizations and send out the copy via different tools. But the core of this workflow was to focus on the stage 2.
Got it. Can you quantify the efficiency? Traditionally, you would probably need several humans, right, on the team to get the outcome that you're getting with this architecture.
Definitely, Rick. That's a good question. So, in terms of the efficiency, I think one GTM engineer is sufficient to build such systems and run them end to end without a lot of manual intervention. It's more about if you architect a system pretty well thought to cover all the edge cases that like potentially the places where your automation could just drop off. Keeping that in mind, if you select the right set of tools, orchestrate them well, and build a correct architecture, I think one person is more than enough to run such an automation at scale. So yeah, definitely, if there are people on the team who are right now doing manually such stuff, acting like analysts, and fetching the review, like they're doing the sentiment analysis part of the review. So for the example I showed, that can be, as I showed, this can be done at a very large scale. So one GTM engineer should be good enough.
And how do you know that it's ready to run? And what I mean by that is if there's one fault in the workflow, in the system, it can mess everything up, right? If the right data isn't collected, then everything onward will break. Basically, at every stage, it all depends on the previous layer being accurate. So tell me a little bit about, is it experimental at first before rolling it out? Can you talk to me about the implementation framework?
Of course, whenever I build such architected systems, never run them at scale. So even if in this example where I showed, I think I ran it only for 3 US locations. I wanted to be pretty sure that my Serper.dev queries are built well enough. All my HTTP requests, all my basically API integrations are working well as my Apify actor. So the recommended approach is, and what I personally follow, is to first test it on only 10 to 15 rows. That helps you with two things. One, to identify where your automation is breaking. And second, when you're working with systems like Clay or even doing API calls, it helps you save a lot of credits in terms of like dollars and cents. So from both the perspectives, first, it should always be well tested. I come from an AI evaluations background, so I am pretty much someone who loves doing rigorous testing and running evaluations on any AI agent or AI automation that I build. So in that way, it gives you like a whole picture of how when you will run it at scale, how are things gonna look like? What would be the success percentage? Let's say if you have built a system that would be only 70% successful or 90% successful in terms of what sort of results we are getting back. All of that can be done with some good amount of testing.
Yeah.
All the things are happening inside my Clay table only, like a traditional software, how it is built, right? One first it is done on local and then it is deployed. So Clay works slightly differently, and it's more about all things can happen in one place itself. That is like the beauty of Clay.
Well, that's all, folks. Thanks so much for joining us today, Vinayak, and sharing your stack.
Thanks, Rick. Definitely, that was great.